Thank you so much for these kind words of introduction. It's really funny. I did my PhD thesis about thermodynamics, and now we're focusing on e-mobility. And I also want to thank the previous speaker for his presentation. We also have similar projects, so there are many connection points here. And we also have those three letters, EMO, so it's quite fitting. First, I would like to introduce myself, and I would like to introduce our institute, and then I would like to touch upon selected aspects of electromobility. I heard about this forum just in the short term, and I didn't really know about the composition of the audience, so that is why I tried to cover different topics in my presentation, and I hope this also works for you. So I will be talking about registration figures, existing versus new registrations. I believe that this is a huge problem in Germany because we have many existing cars in Germany, a large stock here. And then I will talk about forecasts. Your graphs are also based on forecasts. If you're calculating with 48%, the question is, where does the figure come from? I will talk about that later. And then we will talk about efficiency. What does the term efficiency mean, also in terms of hydrogen? And then I will talk about the technology changes. We are a small and young institute. We were founded in 2016. We have 7 professors here in Hannover, so I didn't have to travel that far to come here. And we are dealing with a large array of topics, but there are many different interfaces: mechatronics, electromobility, construction design. So there are many interfaces, overlapping fields. So we need construction, but also electrical engineers. Everything is required in our institute. What are we doing? This is a selection of our projects. We started with a cooperative PhD program, electromobility, and a colleague of yours was also represented here. We were also conducting research on scalability of mobile micro CHP units, and maybe you also know some colleagues from that. Then we also had to showcase electric mobility. So we have been dealing with the topic since 2013, as this has also been funded for some years now. These are some example test benches that we have. So we also have a lot of hardware there. Now we have a new test bench with 200 kilowatts, so we can also test and inspect larger vehicles, and we are very happy about that. And there is a lot of activity going on in our institute. Now, let's focus on the topics that I want to present to you. I haven't timed my presentation before, and I hope that I would stick to the time allotted to me. Let's start with the registration figures. 1 week ago, we had the IAA in Munich, and we came from Munich to Hannover. And in Hannover, we have the HAZ newspaper, and they have surveys, and they ask the people, what do you think about specific topics? So it's not really representative. But as e-mobility was an important topic during the IAA, the magazine asked, or the newspaper asked the people, what do you think about e-mobility? Do you think it's important for the future? There were 7,000 respondents, so it's not really representative. But nevertheless, 27% of the respondents said that they do not believe that e-vehicles will become established, that they will become the thing of the future. So I asked myself, how do they arrive at this assumption, and what do they think will be the solution? We just saw that we have to change 50% of our vehicles, and I also hear it from relatives and friends and also in projects. Many people don't believe that e-mobility will be the solution for the future. We have been dealing with this topic for several years now, but people are not really convinced of that. And the question is, why is that? Now, let's take a look at the registration figures. The registration figures of e-cars are increasing strongly. So this picture looks very nice, but if you take a look at the absolute figures, it doesn't look that nice. And also within Europe, you can see that Germany is also very strong in terms of the registration figures, so that also looks very positive. All in all, you see the dark blue pillar, which is 2021. It's almost double the figures before, so it looks really nice. However, this is an older chart which has been updated, and you can see that the new registration figures are increasing over the past years and decades. So it's about 50 million passenger cars that we have in stock. But if you now consider the electric vehicles, it's only 1 million, it's only 2%. So that's a small share, and this is the main problem we're faced with. And the second problem, if you consider the international market, so you can consider, you can take a look at the figures for Europe. Of course, China is the biggest market, that's well known. And you can see the increase figures here, that's much larger. So if you compare China with Europe for 2022, you will see a huge difference there. So the question is whether Europe and Germany is lagging behind and missing on an important trend. And what is the reason for that? And we also have to ask ourselves the question, where does innovation come from? Why are we doing electromobility? I've been working in the vehicle industry for many years in many different projects, and there are actually two categories where innovations come from. Either it's direct market and customer needs. So it started with the VW Beetle, and now we are at the Golf series. So those are market and customer needs, and it's always a focus on convenience and costs. However, there's also a second sphere where we have social needs, societal needs, and long-term requirements. And those are completely different objectives that we want to achieve. So in Europe and in Germany, this is actually stipulated by the legislator. It's a completely different motivation we're talking about. And this is highly relevant for us. The customers are not buying an e-vehicle because it's faster or better or more convenient, but because the legislator wants this to happen and thinks that it makes sense. So this is a huge difference. The end user doesn't really understand it. He doesn't really want to deal with that. There are different legislative processes, and he's not interested in that. So that's a completely different motivation, and this is also the trigger for the promotion of e-mobility in Germany and Europe. So now let's take a look at the different technologies. So we don't want to have ICEs. We want to reduce the number of combustion engines, but there are several possible technologies. But actually, there are three technologies that are in focus for some years now. So we have e-mobility, battery electric vehicles. Then we also heard about hydrogen fuel cells. There are different terms for that technology, but it's also an electric vehicle. The question is, where does the energy come from? And over the past few years, e-fuels have also popped up. So sun fuels, syn fuels, there were different terms for that. And there was also a political stage for these e-fuels. And the question is, what will be the solution of the future? And the users also ask themselves, should I wait and see? And also for private users, but also for companies, people don't really know where the development will go. And we have so many different calculations and graphs, what could happen, but I'm an engineer, I'm a technician, and I like to calculate things. So in engineering, the efficiency is very important, and I think most of you are familiar with that. So we have this old graph here in order to show in pictures what are the possible drive technologies and where does the energy come from. So maybe you're familiar with that. So if I want to have 100 kilometers in distance or in reach, what do I need in terms of the energy? So on the left-hand side, we have the battery electric vehicles, then I have fuel cells, and then on the right-hand side, I have combustion engines. And the huge difference is the efficiency rate, well-to-wheel, maybe you heard the term. So what is the energy loss when the energy comes from the PV system or the wind power turbine? And actually we have a factor of 4. And if you say, okay, I'm dealing with green energy, that's not too bad. However, I also need a lot of space in order to generate that electricity. Also in Germany, we know the discussion in Germany. It's difficult to come up with new spaces for wind turbines, especially here in Hanover. But we have this problem in Germany as a whole and in Europe. So this is a well-known problem. I cannot just neglect the efficiency. And I just want to simplify things here. And that is why we have this orange box. I'm not a politician myself. However, politicians also get back to the physical facts, which is physics, the efficiency, and you shouldn't neglect that. And that is why we also see this trend towards electrification. And this is also what politics promote here. So this brings me to the forecasts. What are the forecasting methods? There are two types you can use. On the one hand, we have top-down or intuitive, and then we have bottom-up or research-based. So you might wonder what is meant by that. So what is top-down intuitive? Top-down does mean that we have experts coming up with calculations and Excel charts, and however, it's rather the neighbor deciding to have a specific vehicle. This is rather intuitive. And there is a great quote by Kaiser Wilhelm, the emperor: "I believe in the horse, the automobile is a temporary phenomenon." And this is often quoted. He didn't really believe in the automobile. So the question is, how valid can this statement be? He didn't really know about automotives. So for us, bottom-up and research-based methods are much more important. There are huge investments connected to e-mobility, so that is why we need research and calculations. And there are several studies focusing on that. And this is now 10 years old. This is a meta-study which compared different forecast models from different institutions, consulting companies, Fraunhofer institutes. And the question was, what will the development of the market be in terms of registration figures? And 10 years later, of course, you're smarter. So let's just consider Germany here. Do you see your figure? That's really funny. It's just one of several figures. But you can see that there is a large range of figures. And those are all scientists, researchers, and they've done their calculations, and they wanted to calculate how the market will be developing. And I don't know which colleagues of the Fraunhofer Institute came up with this forecast, but this was based on calculations. And this is always the basis for the forecast models. And this is also the basis for investments. This is also an older picture from 2016. And this shows what the impact for the car manufacturers are. So you can see all the vehicle development projects that we had over the past few years. It's not just a single project, it's several hundred of millions dollars or euros which is invested in the development of cars. So it's huge investments, and the investments will only be made if people are really convinced that it will work. This is not just based on a gut feeling. And from my point of view, costs are also very important. We also touched upon that. I think we will also hear about that from you. I'm also very interested in your opinion. This is a graph from 2016, so it's also an older study. And there is actually the crossing point in 2023. What do we see here? It's the battery costs. And the battery costs are going down continuously. So we see US dollars per kilowatt hours for different categories. So we have cells, automotive systems, but also stationary energy systems. And of course, the prices are different. It also depends on the installed capacity. But you see a strong trend here. And the diagram only goes until 2020, and the trend even continued further. So forecast models are not always completely accurate, but they gave good results. And then on the right-hand side, we see two effects. So we see internal combustion engines and we see electric vehicles. And two effects are happening at the same time. In terms of internal combustion engines, the costs for the powertrain are going up. So you see all the different powertrain components which are used for ICE vehicles, and you see the dark blue line. This is increasing. Why is it increasing? Because the requirements in the EU are also increasing. We have more technology, and that is why the internal combustion engines costs will also go up. And then we have the lighter blue curve. The electric vehicle costs are going down. So we have the battery price, which is included here. We also saw that on the left-hand side, but also the assembly technology for electric vehicles is completely different. We see it with Tesla and also competitors in China. And this is market research by Deutsche Bank. And it's very interesting because for this year, 2023, well, you cannot really say whether it's exactly 2023, but they forecasted that there will be a change in the year 2023. So it will be more expensive to build and also sell internal combustion engines, and it will be cheaper for electric vehicles. So I'm very curious about the further development. And the conclusion is that costs will further accelerate market developments in the near future. And this brings us back to the political sphere and the funding mechanisms. This is also under discussion right now, what's going to happen at the end of the year and the beginning of next year. But from an OEM perspective, this is also a very clear trend, and this is measurable. Well, at the end of my presentation, we also want to focus on a different thing. We first focused on e-mobility, and Professor Faustich also mentioned that. And I think several things will change. One buzzword is modal split. So there will be a change in modal split. And the question is, how can cars be replaced by other means? For instance, in Paris, people use their bicycles much more, and there is the wish to have this modal split. And also in Hanover, there is this objective to reduce private transport by 50% by 2035. This is a political objective. There has been a political resolution about that, but this has many consequences on other things. Maybe you've read it in the news, and that's a very exciting effect which takes place at the same time. And this has, of course, an impact on the design of public transport, the capacity of public transport, the connections, also in rural areas. And of course, it also has effects on the vehicle population and on sales. So we have VW here close by, and we have large production figures and investments, and it's directly connected. You will see the effects of that. So this will be an important lever. And in order to come up with a summary, without electromobility, it will not work. This change will not happen. And I just want to show you a final picture in order to show you the speed of technology changes. This is a picture which is 100 years old. It's from the Fifth Avenue in New York City, and there was a large parade. And maybe you cannot really see it on the picture, but you only have horses and carriages, and there was only one car, the first car, which is highlighted here in red with a red circle. And then on the right-hand side, we have the same situation 13 years later. So just a few years later, and it's turned around. So you see all the cars, and on the right-hand side, you can just see one horse. I don't know whether you can see it, but it's just supposed to show that speed can happen very fast. When people think that it makes sense, the speed will happen very fast. So it didn't take too much time to build up this car population, and we will see what's going to happen with us. It will be very exciting. Now, this was a very brief presentation. I hope I stick to the time which was allotted to me. I have already mentioned that we have a large vehicle stock in Germany. The drive technology is important, the cost structure, the total cost of ownership. This will also be important for you. Maybe you will also touch upon that later. And then also the switch from ICEs to BEVs will not be enough. Our mobility behavior has to change, our mindset has to change. And my final conclusion, developments sometimes happen very quickly. Thank you so much.